Let us understand how yarn works. Yet another resource negotiator, that's a resource management component within the Hadoop. We are going to understand the architecture of yarn and how that's going to facilitate to do the processing within the Hadoop ecosystem. Yarn, again, it works with master worker architecture, where we do have a master called resource manager. We do have a master called resource manager, and each worker machine will be having a process called node manager. All the node manager will be reporting to the resource manager in terms of CPU utilization, what job is happening within that particular machine, and what is the utilization of that particular machine. And this particular master worker architecture can be made very highly available by providing more resource manager. As such, n number of node manager will be reporting to the resource manager. This particular environment, it's going to act like a distributed operating system to manage the resources to do any job. I can do any type of jobs like MapReduce job or massive parallel processing. Any job I can schedule it within this particular environment. It could be a Spark job, or it could be a massive parallel processing job, or it could be a MapReduce job. Every job, again, it works with a master worker architecture. A master will get started. Let's take an example of MapReduce job. MapReduce is a methodology to solve any problem statement in a distributed environment. I'll be having a logic which represents what needs to be done against this particular file. For example, let's say file ABC. I wanted to filter out all the error records and count how many error records do I have within this particular file. That logic will be represented using the MapReduce methodology, and we call that as a logic, and we can use any programming language like Python, Scala, or Java. Once we have this particular program, this program needs to be distributed across different worker machines and get the job done. As such, we have two blocks for this particular file A. So I need a copy of this particular program to be deployed into two different machines or in the same machine, where one process per block. So I have two blocks, and a copy of the block will be scheduled to get executed near to the machine or near to the code. A copy of the code will be scheduled to get executed in the same machine where do we have the code. So the processing going to happen locally, and there will not be any movement of data. Once the results get generated, I can consolidate the result. And to coordinate this particular distributed task, there will be a master that gets scheduled. It could be in any of the worker machines or in any other client. For the better understanding, let's say this is called a master, application master. And that's going to schedule this particular job in a distributed fashion. At any point of time, if I want to know the overall status of the cluster or the yarn, my resource manager will be scheduling it, and the status about a specific job, I can get it from that specific master. And the resource manager will be managing the list of application masters handling different jobs. So I may have n number of jobs running simultaneously, and each of the job status and which application master is handling that particular job and where that is scheduled, the entire coordination will be taken care by the resource manager. So in a summary, within the cluster, I will be having one or couple of resource manager based on the high availability requirement, and n number of node manager will be running. These two are Java processes that will be running, and all the node manager will be reporting to the resource manager. This is like a distributed operating system where it is going to manage the resources of this distributed environment. On top of it, n number of application master can get started. The number of application master will be equivalent to number of active jobs running within the cluster. If there are no jobs running, there will not be any application master running. And each application master will have its own freedom to start a number of tasks as per the configuration or as per the resource allocation provided for that particular job or the user. And application master will spin up n number of tasks, and it could be a MapReduce job, or it could be a Spark in-memory computing job, or it could be a Impala massive parallel processing job. It depends on what type of distributed processing I am executing within the cluster. So in a summary, I will be having yarn which takes care of the resource management, and HDFS, which takes care of the massive storage. So together these two provides the Hadoop environment or the Hadoop framework.